Hey guys, welcome to this session by Intellipaat. In this session, we'll be learning Amazon Aurora clusters comprehensively. Amazon Aurora is a type of database engine which is available under the RDS provisions of AWS, and it can be used to create a highly available architecture of a database. Now let us take a quick glance at today's agenda. To start off with this, we'll learn what exactly is RDS. Moving on, we'll learn other choices of databases available on the AWS cloud. Then I'll give you a quick introduction to Amazon Aurora, and then we'll look at the concepts of Amazon Aurora. After learning all the concepts, we will launch an Amazon Aurora cluster, and we'll also do a demo of moving a local database into Amazon Aurora. Also guys, before moving on with this session, please subscribe to our channel so that you don't miss our upcoming videos. And also guys, if you are looking for AWS certification training, we Intellipaat provide a training on AWS Solutions Architect, and those details are available in the description. Now without any further delays, let us move on with this session.
So first we'll be learning and understanding what is Amazon RDS. So RDS, the full form of it is Relational Database Service. It is a web service provided by Amazon, so that this service, it makes it easy to set up and operate a relational database on the cloud. So they provide all the access, they provide all the facilities, which is more than enough to create a database on the AWS cloud, and just change some configurations like the endpoint or the host name. Just change that and it will work exactly like your MySQL database. If you're using MySQL, it will work exactly as a MySQL database, because this particular relational database service is a MySQL service which is running in the AWS data center. So AWS RDS provides these 6 options for you to choose from. First is Amazon Aurora, and then MariaDB, PostgreSQL, Microsoft SQL Server, MySQL, and Oracle database. So these 6 are the options which they provide. And Amazon Aurora is a database service which is provided by AWS themselves. They manage it completely. It is not a different database engine which is hosted on Amazon Aurora. But in Amazon Aurora, they use MySQL and PostgreSQL, but all the functionalities which include those 2 database engines, to make them faster and make them reliable, they made their own architecture on which this MySQL and PostgreSQL engines will be hosted on, so that they become more reliable and highly available. So now, these are the benefits of using RDS. So first, administration burden will be reduced. You don't need to maintain or upgrade or patch your databases. AWS will do it for you. And again, cost effective. You only pay for the hours or the storage of the database which is taken up by the database which you have created. And then security, yes, AWS. So security is basically a shared responsibility. You'll have to take care of not leaking the sensitive credentials. AWS will take care of maintaining the data center. They will keep the data center secure enough so that no attacks are made on them. And then highly available, yes, the architecture is made that you can create multiple databases, multiple readers, and multiple availability zones in one region to make them highly available in that particular region. You can also make them available cross-regionally. For example, if you have one database hosted in one particular region and you also have a customer base in another region, so you can replicate this database into that region and create multiple instances there, so that you can make it highly available in that region also. And then scalability. So basically AWS provides us scalability, that is, they automatically do it for us. They increase the database in 10 GB incremental size. So for example, when there is a need for more data, and they'll automatically add until a certain point. And after that, you can create for example, you can vertically scale also. If you have one particular database instance type and you want more compute power, so you can change your database instance type which has more compute power than the current database instance. And finally, free tier for RDS. So you can see these 6 options. For these 5 options, you have free tier capability. For Amazon Aurora, you do not have. I don't know why, but for these 5 options, they have provided, because these 5 options, in these 5 options, you can use t2.micro. That is an instance type. You can use that instance type database. So that instance type is provided under free tier. But Amazon Aurora does not support t2.micro instance type. So that's why you cannot practice Amazon Aurora for free, but you can practice the other databases for free. Moving on. Now, which AWS database to use when? So here you can see two database types, two use cases, and the AWS service which can be used for it. So relational. You can use Amazon Aurora, RDS, and Redshift. So Aurora and RDS are traditional database types. So you can use them for traditional database needs. And Redshift is a warehousing tool. You can use Redshift for example, you can store your operational data so that you can take that data and analyze it and create some visualizations. So Redshift is a warehousing tool, and Amazon Aurora and RDS are relational databases. You can use these for traditional applications, for ERP, for customer relations management, and also e-commerce websites. So these are few use cases. And coming to DynamoDB. So DynamoDB is mainly used for high traffic web applications, for example, Amazon.com, or which requires a lot of personalized content. For example, if you go to Amazon, you might get not in Amazon, if you go to Google, you get personalized ads. And even though you go inside Amazon.com, if you want to search for a particular brand, a particular shoe, so you just provide its name, you filter it out. So to get that data and give it to you back. And same example with gaming applications. So if you would have played PUBG or any battle royale or any kind of games, there will be a leaderboard for every region. So you can click on the leaderboard and you'll get data within seconds. And that for that particular application, you can use DynamoDB because it gathers the data of that region at that particular time and it gives it back to you in a fraction of seconds. So you can use DynamoDB for high traffic web applications and again e-commerce websites. There can be two different databases used for the same application for different purposes, and then gaming applications also, as I told you, for leaderboards. And finally, for caching, you have Amazon Elasticache. There are two types, Memcache and Redis. So I think Redis is better than Memcache in a lot of sorts, but these are the two available options for caching in AWS. So you can use it for caching and also you can use it for gaming leaderboards, because if the data is not changed for the gaming leaderboard, for example, weekly leaderboards, so the entire week the leaderboard will be the same. So you can keep the same and you can store it in the cache memory so that every time somebody checks for the leaderboard, it comes back.
Okay guys, a quick info. If you are looking for AWS certification training, Intellipaat provides a complete AWS Solutions Architect certification training, and those details are available in the description. Now let us continue with the session.
So now, where do they use DynamoDB? So this is an actual company which uses DynamoDB. You might or you might not know Duolingo. Duolingo is a course provider. They provide courses on languages. So they have 18 million monthly active users. They have 80 different language courses and also 6 billion exercises every month. So you could think of the amount of data which Duolingo needs, because they provide courses on 80 different languages and also they have 18 million different users. So that data has to go to all of those users, all of those single users. So for that, they have used DynamoDB so that they can gather data in a faster rate. So they can they can retrieve data faster than normal databases, traditional databases. And DynamoDB is a key value file database. Like you can store data in JSON format. And so this is one of the examples for that. So you can see, let us consider Amazon.com. So you're placing an order. So that order is stored in the operational database in DynamoDB. So you might or you might not know Lambda. So let me give a basic idea of Lambda. Lambda is a service which will run a set of code which you have mentioned in Lambda as a function. So whenever there is a particular action happening in DynamoDB, Lambda will automatically be triggered. For example, if a new order is placed, when there is a put operation, Lambda will get automatically triggered. And now a use case for Redshift also. I wanted to show a use case for Redshift. So now that data will be pushed into Redshift. So now Redshift will contain all the operational data. So now you can use the Redshift data to create analytics. So you can create some visual graphics and you can create some data visualizations for your company, for your organization. So this is the use case of DynamoDB and Redshift. These are used in various places. In what places you use warehouse, you can use Redshift over there instead of any other service. And For a key value file database, you can use DynamoDB, because if a company the size of Duolingo uses DynamoDB, even you will also get benefited by using DynamoDB. Now coming to Amazon Aurora. So Aurora is a fully managed relational database engine that is compatible with MySQL and PostgreSQL. So as of now, MySQL and PostgreSQL are the only compatible database engines with Amazon Aurora. So just a second. Okay. So as I told, you can only use MySQL or PostgreSQL for Amazon Aurora. So when creating a database in Amazon Aurora, you get the option of either choosing MySQL or PostgreSQL. Now Amazon Aurora, so you will be already using your MySQL or PostgreSQL database locally for your local application, or internally you might be using within the company. So you can use this code, the same tools, the same application you use with the existing MySQL and PostgreSQL database with Aurora also. You will just have to change a few configurations. For example, in the local, let us consider you're using XAMPP, and the type name would be, host name would be localhost. So now if you just change localhost to the endpoint which is provided by Amazon Aurora, it is more than enough for you to write data into Amazon Aurora and read data from Amazon Aurora. So as I told you, it is compatible with MySQL and PostgreSQL databases. And performance, so Amazon Aurora's architecture is designed as such, it provides you high performance, because in Amazon Aurora the storage and compute is separated. That I'll come later.
Okay guys, a quick info. If you are looking for AWS certification training, Intellipaat provides a complete AWS Solutions Architect certification training, and those details are available in the description. Now let us continue with the session.
So now let us see this. So without changes to existing applications, Aurora can give pi into throughput of MySQL and 3x throughput of PostgreSQL. And in Amazon Aurora, for 1 DB cluster in the sense one primary database and one read replica. So for that, you get 64 TB maximum size. So the minimum would be 10 GB when you create a database. The minimum size would be 10 GB, and for MySQL, it can go up to 64 TB. For one database cluster, and for PostgreSQL it can go up to 32 TB, and the minimum is the same, it is 10 GB. Now coming down, so now let us discuss about Amazon Aurora's database clusters. Database cluster consists of one or more database instances and a cluster volume. So you can see the compute and the storage is different. So in Amazon Aurora, the architecture is designed as such, the compute, that is this part, and the storage is separate. And when you create a database cluster, you will be provided with one primary instance, and you will be given 6 different data nodes in 3 different availability zones. So you can see there is an availability zone A, you can see there is an availability zone B, and you can see there is an availability zone C. So now when you create a database cluster, so let us consider these replicas are not created. So now you created one DB cluster, and there is one primary instance created in availability zone A, and you will be given these 6 data copies in 3 different availability zones, even though there are no, for example, you are only creating an availability zone A and you don't have any database instances in the other availability zones. Even if they are not available, you will still have data copies in those availability zones. For example, if you are creating a replica later, for example, after 1 month you are creating a replica, so now you will need a data copy. So instead of creating a data copy at that time, it already has a data copy in that availability zone, and then if you create an Aurora replica, it will automatically take data from there. So now whenever data is written to one particular primary instance, so for example, when a user is registering, so this is the only point where he can write, and these are the points where they can read from. So the data is stored here, but you will have different endpoints for this primary instance, for this replica, and for these 2 replicas. You will have separate endpoints. You will have to specify those endpoints in your code so that you get this particular for example, if you mention the endpoint of this read replica in one particular, for example, let us say for login, you only provided this Aurora replica. So every time that data will be taken from this Aurora replica. The data will be read from this Aurora replica, not any other Aurora replicas or the primary instance. So now whenever you create one DB cluster, one database cluster, it will have one primary instance and one read instance under the same availability zone, and also 6 data nodes in 3 different availability zones. So this, while I'm creating a database cluster, I'll explain it in a way that you get to know where this primary instance is available and where is the replicas, because I'll show you how to create a replica also. So now these things cannot be proved, these cannot be taught you with a proof of concept, because these reside at the back, these reside in S3, but I can show you where they are stored and why the architecture is like this. So now let us move on and check this. So first, primary DB instance. So as I told you, the primary DB instance supports read and write operations, and any data modification operation for update or delete, anything happens in the primary database instance if it is a single master database cluster. As I said, single master database cluster in the sense there is only one primary database instance. You can also create multi-master, that I'll come later.
Okay guys, a quick info. If you are looking for AWS certification training, Intellipaat provides a complete AWS Solutions Architect certification training, and those details are available in the description. Now let us continue with this session.
Now let us understand primary database instances and Aurora replica. So now, primary database instance is the only endpoint or the only place where you can read and write and also do other data modification like delete and update. And also, now coming to this, Aurora replica connects to the same storage volume of that of the primary database instance. They are the same volume, but Aurora replica only supports read operations. Now here you cannot, in these replicas you will not be able to write. If you write in this primary database instance, it will be replicated in this Aurora replica once the change has been made. So if you come to this slide, you can see that. So once the change has been made in this primary instance, first it will be happening synchronously. So at the same time, when there is a change made here, for example, if there is a change made in this primary instance, it will be copied to this data copy, it will be copied to this, and it will be written in this. So synchronously it will happen to all the data copies, so that when somebody once you change something here and when somebody is trying to read that same data from the Aurora replica after it gets written on all the 3 data copies, they should be able to access it from this replica also, because once this is written in this volume, in this data copy, that means this replica can access this and get the data out of it, because all the volume are common for all the availability zones, not like the DB instances. The database instances or the Aurora replicas are just for that particular availability zone, but the cluster volume is common for all the availability zones. So you can see each Aurora database cluster can have up to 15 different Aurora replicas in addition to the primary database. So what does this mean is, for example, coming back to this, so you have 3 availability zones. So let us consider in availability zone A, you have the primary database instance. Now your application is very read intensive. So many people are trying to read data. There is a lot of workload. So what you do, you want 15 Aurora replicas. So what do? You can create Aurora replicas in this availability zone and also in this availability zone and also here. This is somebody trying to, I'll continue that. Okay, so you can create 15 Aurora replicas within these 3 availability zones. So for example, you can create 3 here, you can create 5 here, and you can create the rest here. But you cannot create more than 15 Aurora replicas. AWS does not allow you for that. Instead of that, you can create a clone of this database, then create Aurora replicas of that clone. So that we'll discuss later. So connection management, in the sense, now we come to the endpoint part. So Aurora involves cluster of database instances instead of a single instance, as I told you. If you use RDS, it only creates one instance. You can create read replicas after that, but when you create an Aurora instance, it creates one main primary instance and also one read instance within that particular availability zone which you created it. So now the host name of that primary database is called the endpoint, and also the read instance. That read instance will also have an endpoint. That endpoint, again, it is also called an endpoint, but it is called as a read endpoint. As told you, it's a reader endpoint. So there are three different types of endpoints. One is cluster, one is reader, and one is custom endpoint. So Aurora, as I told you, it involves a cluster of database instance, not a single instance. And why do we use endpoint mechanism? Because you don't need to write your logic for balancing the load in Aurora. It reroutes to the healthy instances for you automatically. So when one instance, for example, in one region, you have 5 replicas. So somebody is trying to read some data. Let us say there are a lot of people trying to read some data, and suddenly 3 of those instances go unhealthy. So now the endpoint for all of these 5 different instances will be 1. So now when whatever, you don't need to change the endpoint now. The same endpoint will take you only to the healthy. It does not take you to the unhealthy instances. Once they come up, then it automatically balances it. So now when there are only 2 instances available, all the coming instances, all the coming in requests, connection requests will go alternately. That Amazon Aurora will take care of. It will balance our load for us. And if there are 5 instances, now the load balancing will spread and the connection requests will go to all the 5 different Aurora replicas. It will use all of those Aurora replicas. Now cluster endpoint connects to the primary database for that database cluster. So you get a cluster endpoint, which is the primary database's endpoint name, which is the host name of the primary database, and reader endpoint connects to one of the available Aurora replicas in that database cluster. So as I told you, if you have 5 replicas in one database cluster, it will take you to one of that database replicas. It won't take you to everything. It will take you to one Aurora replica in that cluster. So it will take you according to the maybe CPU util that Amazon Aurora takes care of. It will check the utilization of all the Aurora replicas. If one is less, it will take your connection request to that Aurora replica. And coming to custom endpoint, you can also create your own custom endpoint by selecting few database instances. So for example, you just want, if you are testing in one particular Aurora replica, so you don't want to use that Aurora replica for some time. So what do? You can create a custom endpoint which only uses few database instances which you select. So now, as I already told you, now let us consider again there are 5 instances, and in that one instance you are using it for some testing purposes locally. So now there are only 4 database instances, 4 Aurora replicas. So you can create a custom endpoint and choose all of these 4 and now change the endpoint to this custom endpoint. So now whenever there are connection requests coming, it won't even care about the other replica available, the 5th one. It will only go to the 4 which are connected to this custom endpoint. So it will automatically load balance it for you. You don't need to do anything else. It automatically load balances. So these are the 3 different types of endpoints. So as I told you, now let us look at the structure of it. So now the master, this is the only primary database instance, and these are the data copies, and it is in 3 different availability zones, and these are the read replicas in these availability zones. So this is one Aurora replica, this is one, and this is one. And for master, you have one cluster endpoint. For these replicas, you have one reader endpoint. So now you can see the users are the same. So when they are trying to write or read, if you are using the cluster endpoint, it goes to the master, get the data from here, and it gives it back to the user. Now if you are using the reader endpoint, it goes in here. It can take you to any one of these replicas. You won't know that. You cannot know which replica it is going to take you to, but it will take you to one of the read replica, get the data, and send it back to the user. So using reader endpoint, that is the main use. You can use the reader endpoint for just reading and use the master endpoint for writing, which will segregate the workload across reading and writing operations. And before that, I have a local application which I have already. So just a second. So it was. So I'll just register region are replicated with typical latency of less than 1 second to secondary AWS regions. As I told you, what if you choose global, you can create database instances, primary database instances in multiple regions. But again, there will be only one primary AWS instance where you will write, but they will be replicated in the secondary AWS region in database instances within seconds. So if they are telling us they will do that, that will happen in within seconds. So you can use global or you can use regional. So now we are going to go with regional. We are going to create one database cluster in one region. And database features. So there are four different features. One would be one writer and multiple readers. As I told you, this is the typical Aurora cluster. That is, there will be one primary database instance where you can write and read, and the rest of them are Aurora replicas. And then this one is multiple writers. So in multiple writers, what you can do is you can create multiple primary instances in all the availability zones. So you can see supports multiple writer instances connected to the same storage volume. This is a good option for when continuous writer availability is required. So for a write intensive application, you can use multiple writers because you can create a custom endpoint with all these three database instances, so that every time somebody is registering, first time it goes to the first database instance, second it goes to the second one, third it goes to the third one, but every time there is some data change in one of those instances, it will be replicated in all of the instances because the storage is the same storage. All of them have shared storage. So yes. Then there is one writer, multiple readers, parallel query. So this improves the performance of analytic queries by pushing processing down to the Aurora storage layer. So I think you can connect this with Redshift and use for operational data purposes. So you can use it for analytical queries to get a lot of data, and then server provide a lot of information. Actually, you just specify the minimum and maximum amount of this. Aurora scales the capacity on database load. This is a good option for intermittent or unpredictable workloads. So what you can do in serverless is, for example, you think your database will always have an amount of 10 GB to 100 GB of data. So now you can specify that storage space, and also you can specify the processing power. So you can specify you need 10 virtual CPUs, that is the minimum, and 200 virtual CPUs as maximum. So now what Aurora will do for you is, whenever there is, it will check for the workload's capacity it needs. If the workload needs 20 GB of data and also like 20 vCPUs, it provides it. And if it requires more now, there is a lot of data coming in and the processing power is increasing. So now it provides you with more vCPUs and it will also provide you with more storage space. Now, a lot of data is getting deleted. Now again, it will reduce the storage space. Also, it will reduce the processing power. It will it will decrease the number of vCPUs provided. So this option is a good option, and also here you will not pay for the maximum amount. You will only pay for the size of data which is stored at a time, and also the vCPUs used. The total hours of the running hours, the total running hours of those virtual CPUs, only you will get billed for that. You will not get billed for the maximum number you put. If always your databases are using the maximum capacity, then yes, you will be billed for the maximum amount. But for now, you won't be billed. You will only be billed for the amount of database usage and the CPU usage which your application is using. So now I'm going to go with one writer and multiple readers. Now, for Amazon Aurora, there is no free tier capability. You don't get to practice in Amazon Aurora, so they charge you. I'm going to go with a dev or test environment. So, if you go with Amazon RDS, then you get a free tier. So I'll just choose something. Let's see. Oh, yeah. So you can see there is a dev and test, and also a free tier. So a free tier in the sense, you can only use one database type. There is only one instance type, which is t2.micro. So only that instance you can use, but you won't be billed for that. You can use a total of 750 hours in that particular database instance. So that 750 hours is calculated for 1 month, and for example you run 5 instances, the total of that 5 instances is less than 750 hours, you will get it for free. If it is more than 750 hours, then you will be billed for that. So now Amazon Aurora does not have the free tier available, so I'll just go with dev or test environment. And you can name your database clusters, so let it be one, not a problem. And then master username can be happen, not a problem. Then master user password you will have to provide. So this is to access your database again. So now I'll just go with a simple password. Yes.
You were saying there's no free, that means if we do our lab ourselves, we won't be able to pick this option.
No, I didn't get it.
There's no free tier option, you said, you mentioned
Yes,
about
for Amazon Aurora, yeah.
Yeah, so if we want to practice, do some lab.
You will have to take test.
Okay, so for selecting that is free too, right?
No, it is not. You will have to choose. I'll tell you, if you want to practice, I'll tell you what to choose. Either choose T2.small or T3.small, because they cost you like $0.02 per hour or $0.002, something like that. So if you use memory optimized classes, they'll charge you more. So for practice, you can use burstable classes. You can use T3.small. So they provide you 2 virtual CPUs and 2 gigabytes of RAM.
If they charge or not, do they list it there so we know? We don't get in trouble?
They provide that. So we'll have to go to the
on the right hand
pricing
side
options to see that. So you want to see that right now?
No. Just want to be careful for the team that if we want to practice, we know what to choose.
No, I was charged very less, so let's see.
It will be incorporate the price onto that page.
It's over here. So for T3.small and T2.small, it is $0.041, and for everything else, it's a bit more. And for memory optimized, it's more. It's more expensive than this.
That's per hour, so we need to be careful.
Per hour, yeah, it's per hour.
So we shut it down right after.
Then you'll get charged like a percentage of it. You'll get charged for that minute you use.
Okay.
Yes. So next is availability, and so I'm going to choose T3.small.
In this drop down, it is saying EBS.
Okay, then just a second. Okay, so the backups are taken in S3 and the storage. I got it. So the backups are taken in EBS, and the storage is the backups are taken in S3 and the storage is made in EBS. So I gave you the wrong information at the start as S3 as I read at that time. So I confused between the backup storage and the actual storage.
Okay, so even in this case, we'll be charged for the 6 GB and not just for the 1 GB, right?
So just a second. But I think you'll be charged for the 6 GB.
Okay.
So I think that's correct.
So actually, that means you'll be charged in EBS. So how much charge you get for EBS will be charged about that. So I think yes. Okay, we'll see this. That is multi-availability zone deployment. So as I told you, while creating a database cluster, you can either go with multi-AZ deployment or don't create an Aurora replica. So when you use this, what happens is when you create this database cluster, automatically they'll create one Aurora replica or a reader node as it's another name for Aurora replica. So if you create an replica while creating, so when you create, that replica will be already available. But when you click on this, then after creating the database and after doing all the operations, then you will have to create a replica. So I'm just going to go with this. I'll be showing you how to create a replica inside the console. So right now I'll just go with don't create an Aurora replica. So I think this will do good. And then VPC, I'll just go with my default VPC. And then additional configuration, yes, it should be publicly accessible. If it is not publicly accessible, then you'll not be able to view your database. For example, you cannot connect it to your local MySQL shell. The thing is, you can connect your uh, Amazon Aurora's endpoint and view the tables inside Amazon Aurora's endpoint in your local MySQL shell also, in your even in the XAMPP shell also. So you can use the endpoint to do that. So yeah, I'm just going to go with that. And again, the security group is going to be default. I'm not going to change anything right now. And here you can choose one of these availability zones where your primary database should be available. So actually, primary database is for the entire region. But when you create, there will be another instance created with that primary instance, right? As I told you, it is a cluster. A primary instance and a read node also will be created in the same time. So now, if you choose one of these availability zones, that reader node, that reader endpoint will be in that availability zone which you choose here. But I'm just going to go with no preference. And then coming to the other options. So here you can see the database options. This is the database instance identifier. This is the name which we give for that. And this is the database name inside the database. So once you create, there will be default databases like test and other databases, I don't know. So there will be a database like that. Here, if you enter a database name right now, so once this database gets created, then you can go inside and check whether this particular database name is available or not. So I'm just going to give the database name which I use in my local application also. So it is going to be registration, and these are the parameter groups. So why 5.6? Because the you can see over here, yeah. So the MySQL which we choose is a 5.6 version. So a parameter group is nothing. It just gets the data of. It will just store the data of what kind of a version is it using. So you can use this parameter group to create another database cluster of the same type. So you can choose this, and this will be chosen in default. You cannot change these parameter groups. Once you choose a version, it will be automatically taken. And next is failover priority. So now when you create a database, you have a primary database and a secondary. So now you can choose the failover priority. There are 15 priorities because you can create up to 15 replicas. So for example, let us consider you have created 15 replicas, and for one first replica, you have provided tier 1. And for every other, so for every other replica you create, you provide a different tier. So now why is this? Because if your primary database instance goes down, whichever Aurora replica has the tier 1 failover priority will be made as the primary database. It will be provided with the right privileges. So that's why they provide this failover priority, and it is up to 50. Tier 0 to tier 50. So you can provide for the primary till the what is that? Yeah, till the 15 replicas. So, but what if uh, you provided the same, for example, you provided tier 0 for two different database replicas. So, that will be considered accordingly. That will be taken care of Amazon Aurora. It will choose one of those and provide the privileges. So, it might choose according to the database capacity. For example, you provide a different class for that Aurora replica. So while you create that Aurora replica, if you want that Aurora replica to be more powerful, so for one Aurora replica, you provided the highest database instance type, and for the second Aurora replica, you provided just T2 T3 dot small. So now Aurora will check between these two different Aurora replicas, which is the most powerful, and then it will provide that the failover priority. So that instance will be made the number one primary instance. So that is why you will have to provide here. But I'm just going to go with my preference again. And then backup. So backup retention in the sense you will be taken. You can see choose a number of days that RDS should retain automatic backups for this instance. So, for example, right now you have some data. So that data will be automatically backed up, and if one availability zone goes down or your data goes down, so what you can do is your data will be backed up in S3. So now what you can do, you can use that snapshot to create another database cluster. And if you create that, yes, the data will be the same because the snapshot contains the data up till the point where it got lost. So that's why you can choose this, and you can retain the backup retention data up till 35 days. So up till 35 days, the maximum moment of retaining automatic backup is 35, and the default period is 1 day. And also, if you are providing any tags for this database instance, it will be also copied to snapshots. So why tags? Tags are just to monitor or track. For example, you will be given a tag for one database instance, and that snapshot will have the same tag so that you can understand this particular snapshot is for this database. And if you have another database and you again copy it back to that snapshot, so you can differentiate between which snapshots are for which databases. So that's it. That is the use of this tags. And then enable encryption. So
sorry, question. The snapshot is the same thing as backup, right?
Yes.
Okay,
snapshots are the name for that.
Okay, so this is, in other words, it's copy text to backups, right?
Yes, exactly.
So it's just
copy tags in the sense the name of the snapshot will include this tag also to understand.
Oh, okay.
Yes, so this backup is for this particular database instance. So tags are just to keep track of them.
Okay, so what if I want to keep backup over 35 days? I want to be longer.
No, you cannot. These are automatic backups. So these are used for point-in-time recovery. So after that, again, another backup will be taken. That will be again saved for another 35 days. Then the next day, another backup will be taken. It will be stored for 35 days. And it's not just one day you can only take backup once. You can take multiple times, and also you can manually take backups also. So I think the maximum retention period for an automatic backup is only 35. What you can do is you can manually create a snapshot. That snapshot you can keep it for a year or 2 years, or you can keep it for your entirety. But automatic backups can be retained for only 35 days.
Okay, got it. Yeah. The automatic backup, is there a schedule that you could specify, or it's Amazon?
For example, let us say at 5 o'clock your database goes down. So at 5, it will check for the latest time when the database got backed up. If the database got backed up at 4:50, then it will take that snapshot and recover the database.
Do you have control of when the backup runs?
Yeah, I think you can set up that. I think you can set it up.
Another interface.
No. I think you'll have to create a automatic backup setup for that. Or no, I think you don't have access. I've never seen a automated backup access in the creation console.
Okay, so does that mean later on you will go to another interface to set up when the backup runs?
There is a snapshot interface separately.
Okay.
Yeah, I'll show that once I created this. We'll go inside that and explore that part also.
Okay.
Yes. So now encryption, this will automatically be done by AWS. So it takes the default RDS key and encrypts our data. We don't need to worry about this. This is AWS part. They do it for us. And this is the key ID. And then backtracking. So backtracking in the sense, if you have created a snapshot, 2 days ago, and you need to make your database as the same as the data which was available 2 days ago. So now you can enable backtracking and provide the number of hours it can backtrack. You can provide 48 hours, so it goes back in time. It does not go back in time. It checks for the 48 hours what and all data modifications which have been made, and the most recent snapshot which was taken will be taken into account, and the database will be recovered. So you can see this here. Backtrack lets you quickly rewind the database cluster to a specific point in time. So you can go to that specific point in time where you took that snapshot and get it back. So without having to create another database cluster. You don't need to create another database cluster. The same database cluster will be recovered using that. So you can provide the number of hours over here for the number of hours which it can backtrack, and the maximum is up to 72. And you can see it over here, typical user costs. It costs you $57.52 a month for db.3.small, and let's give 72. It becomes 86. Yeah, it costs some money. So if you want backtrack, I think you can backtrack it for a database which is the data stored in it are really valuable. Then I think you can use backtrack. And then enhanced monitoring, again, this will cost you, but this is if you are using a separate monitoring tool for monitoring these databases, then you don't need to enable this. Basically, this will provide you more metrics. This will provide you more insights. But if you want just the basic metrics like CPU, util, and stuff, and for that you don't need enhanced monitoring. CloudWatch provides you for that for free of cost. They provide you default fee, and then you can also so some logs will be published in CloudWatch. You can select the log types which has to be published to CloudWatch also. The audit log, or if any errors, that logs, or any normal logs, written, write log, read, all those queries, all those logs can be published in Amazon on CloudWatch, and you can get those logs from CloudWatch. So I'm not going to use logs right now. So it is, if you want any error log, for example, you want to check all the errors which were happening so that you can rectify it in the future, you can just click on this. All that error logs will go to a particular Amazon CloudWatch group. You will have to go to CloudWatch. You will get the name of that CloudWatch group, because it will take the name from here, whatever database instance we create, database 1. So you can go there and get those logs from the CloudWatch log console. So you can use log exports for that. And finally, maintenance. You just
one question on the one question on the log was, so will it be having any performance impact on the application?
No, it does not.
So this is separate.
Because all the logs will be taken from, I think, the storage. So if there is any fault, that's what I read from the white paper. So what they explained was, as everything is separate in the Aurora architecture, so there won't be any impact in the performance of the application. So this process will be taken care by CloudWatch. So CloudWatch will be responsible for getting the log, check for each and every step going on. So it does Aurora.
Okay, and it will be utilizing the same CPU which is allocated for the application,
so,
right?
Yes, it does not. It will be using the same, and the storage or anything else. So CloudWatch is responsible for that now. So you'll have to go inside CloudWatch and get those logs. So now the logs will not be stored in Aurora storage. It will be stored with CloudWatch.
So in terms of the audit log, is there another interface to configure what to audit?
Yeah, you can do that.
Okay.
Yes, you can do that. So you can use CloudWatch for that.
No, I mean,
so these are just, you will get all the logs. If you choose these, you will get all the logs in CloudWatch. Then from there you can filter it. There is no separate user interface for just getting a particular log.
So if you check audit log, so by default, it's going to audit everything, and then you go to CloudWatch to
Logs.
get the audit log and filter out what you need to see, right?
Yes.
Okay.
So if not selected, this will be captured, or any way to check the error log in DB level, or it will be captured in Amazon logs then, right? Amazon servers.
Yeah, it will be captured in Amazon servers. Yes. Nobody's speaking. Okay. So I was at this maintenance part. That is, if you enable auto miner version upgrade. So what it basically means is AWS will do all the miner version upgrades for you. So if there is any update or patching required for that particular version of the database, then AWS will do it for you. You don't need to do anything else. Or you just have to pay the money which you normally pay for Amazon Aurora, and they'll do all the version upgrades and stuff for you. And also there is one more thing, maintenance window. So when there is maintenance going on, so there will obviously be some delays in it. So there will be some, it will affect the performance. So here what you can do is you can create a particular time, and at that time you can have another setup made in another DB cluster just to use for that particular period of time where it will maintain. So you can see half an hour is the least. So it will maintain your database for half an hour, and once it also you can choose the time when it is very least used. You can choose the day also, you can choose the time also, you can choose the duration of that. You can also, for an entire day you can do, but your database will be still available to read and write, but it will have a few performance issues because AWS will be working on it. So this you can select, and also you can give no preference, but I'm going to give no preference because my application is not going to have a lot of users right now. And finally, deletion protection is, if you click on this, you cannot go to your database instance console and click on the database instance and go to actions, click delete, and it won't delete. You'll have to go inside your database, modify it, and remove this enable deletion protection. Once you do that, only then you'll be able to delete it. So this is just to prevent carelessness. So if you're trying to click some other option, if you click delete, you will get a prompt, but still there is an option to enable deletion protection, and this is to protect from accidentally deleting your databases. So now let us create the database.
So one more question about the minor version upgrade. It's online upgrade, right?
Yeah, so it will be happening in the data center.
So I mean, doesn't it affect the database? If I have load going on, and it just happened that Amazon's doing the minor version upgrade.
Yeah, there will be a little bit of performance issues at that particular time, but obviously you will have how to say, all the availability zones, the version upgrades will not be happening at the same time. So if one availability zone is having less performance, it will take your connection requests will be taken to the other Aurora replicas by the endpoint.
It's online. Everything's still online. Okay.
Everything is controlled by Aurora. So yes, it load balances for you. So that's why even though the performance delay is there, for example, if the version upgrade is happening in all the regions, then yes, there will be some delays.
And the configuration of failover, I don't see for master database. If it crashed, does it fail over to?
That automatically happens. As I told you,
the priority. I saw the priority setting. That's which one is used for the read replica.
So here, yeah. So if you select one of this, it will be taken for the instance which will get created with the primary database. So the primary database will not have any failover priority because that primary database is going to be failed, right?
So this failover priority is for the primary to fail over and act as primary. So I see the sequence from 0 to 15. So there's 16 of them. Okay.
Yeah, there is 16 of them. So you can create multi-master clusters also. You can have, like for example, you have two different database clusters. Then you'll have 30 Aurora replicas, and you can use these tiers. So these don't. So this is provided by AWS. This is just to mention your priority. I don't know why there is 16, but yes, there is no priority needed to be provided for your primary database. You just need to provide it for the replicas. So even if I provide a priority here, it will be taken for the read node, which will be getting created.
So if I set up no preference, and Amazon will primary database to just anyone,
so
right?
If you don't prefer any, if you don't provide the failover priority for any of your Aurora replica, then it will choose, AWS will choose automatically. It will choose which replica to provide the privileges to.
And that one will become a primary.
Yes.
Okay. Thank you.
Yeah. So
one question for the DB upgrades. So these DB upgrades, is it like controllable by us? Like let's say Amazon decided to increase the version of this MySQL 5.6 to some other version, right? So can we control this if we don't want this upgrade?
No, it's not like that. So if you choose 5.6, then the version will be 5.6. Minor upgrades, in the sense the data center upgrades, maybe for example, you are trying to increase your instance type. That will be made by AWS. So when your database will be shifted from a lower capacity instance, for example, 2 virtual CPUs to 5 virtual CPUs, then that will also be a upgrade from one instance type to another. So it will not, if you choose 5.6, then it will not change your MySQL version.
Okay, so it is all about the patches for the DB updates.
It is all about the patches.
Okay. And all those patches will be controlled by checking that box like automatic minor updates.
Yeah, it will be taken care of. They'll take care of it. I think if you don't provide it, I think we'll have to do that. I have not worked with that actually. So as far as I know, that is AWS does everything for us. That is the minor patches, everything will be done by AWS.
And those patches could impact my application too, right? So that's why I'm asking. So if we selected that, saying okay, I'm okay with minor updates, which could include patches. So
you can cancel that. Yeah, you can just uncheck that box.
Right, but if I checked it, so will they give like advance notice saying by this date this patch will be applied, so the application has to be compatible with that, or like they just do it by themselves at some point of time?
Thing is, I've never had an application running, and I've never got anything like that, so I can't answer that question, but I'll check into that, because whenever I create a database, I provide that, because I've never had a time to uncheck that. I always check it, but I'll check into that question and I'll answer in the next time when I'll be using MySQL and PostgreSQL in Aurora.
Yeah, so, thank you.
Yes.
I have a question.
Yes.
So do we have an option to auto scale the writer instance?
Auto scale the writer instance? You can. You can create, you can see over here, you can create a clone. You can also create a cross-region preset, because if you create a clone,
it's something that I clone and then have it running, right? So that would be kind of paying for 2 writer instances. What I'm asking is, like, can we auto scale based on the resource utilization? Let's say if my CPU is more than 80%, I just auto scale to another writer.
Yeah, that you can do. Yes, that I think you can set up an alarm, and once that alarm exceeds the condition, then you can increase the size or you can change the instance type. So there is that. So we provided t3.small, right? So I think you can automatically upgrade the instance type so that you get more storage and also.
No, but if we change the instance type, then that's a vertical scaling, right? Which means that
Yes.
there's going to be some downtime. But what if I'm looking for an horizontal scaling?
So that's what I told. The maximum, if you consider storage, the maximum one Aurora DB cluster can go is 64 terabytes. So after that, you will have to do horizontally. For PostgreSQL, it can go up to 32 GB. After that, you'll have to go horizontally.
Storage. What if, let's say, if my resource utilization is more than 80%, and I want to spun up another writer instance, which gets attached to the same cluster endpoint.
Okay.
Can I do that?
Yeah, yes, you can create an alarm for that, and you can create a group where you attach all of these database clusters and launch one more instance.
When you say resource, you are either talking about CPU or talking about memory, right?
Yeah, that's right. CPU or the database connections or memory.
Yeah. Right. So
I think there is a replica of writer auto.
Yeah. So I just want to know if there is a functionality built in, or we need to do something on our own.
So there should be an option. I'll just a second. Monitoring. So I'll do that. Like I'll do that automatic scaling if it is available in the next session. I'll do a demo on that.
Okay.
Is it fine? Yeah.
Yep. Should be fine.
Yeah.
Thank you.
So now we've created a database cluster. So this is what I mean by a cluster. There is a main database, which is regional, and there is a writer. So if I click on this, if I go inside, you can see two database endpoints. One is the writer, one is the reader. So as I told you, for a cluster, there will be one writer instance, which is the primary database, which can both write and read, and there will be a replica created in the same availability zone as of that. Like for example, it can be in any availability zone because I gave no preference. So it is in US East 1D. So this replica is in 1D. So now if I provide this endpoint to read my data from the database, then yes, it will directly go to my read replica in that availability zone and get the data back and read. And if you want to write something, you can use this. But same, if it is a small application, you can just use this and access both read and write. But if it is an application which needs high availability, you cannot just go with one database cluster. Either you can go with multiple database clusters, or you can create. So here, this is my localhost. This is my local system, which has the database. So there are some commands. I think you'll obviously know that. Where is it? So I just used MySQL dump, which is already available in my registration, but I'll do it once again. This is my local database. So I'm writing the data in my local database into a registration.sql file, which is in this location to this. So once I do that, I can use that SQL file. I'll run that SQL file when I connect the database using the Aurora instance. So once I connect that, I'll be able to import that data by using this command. So I'll push this commands inside this SQL file that will be run inside my Aurora database. So this I'll have to change. The endpoint I'll have to change. So once I change that and run this, then the data which is stored in my local will now be stored in my Amazon Aurora cluster, So now I can go inside my code and change the endpoint from localhost to my Amazon Aurora's endpoint. So that will make the transition seamless. So these are for small applications, but for huge applications, when your database server has an IP address, we can use database migration service. That is a separate topic. We'll not go into that right now. We'll do that in a separate session. Right now, we are just going to make a SQL file which will run in the which will all the MySQL operations will be done on Amazon Aurora database, which will create a table which will put all the data from my local inside the uh, Aurora, and then we'll just change the endpoint from localhost to my endpoint which is provided by Amazon Aurora. So first let us run this command and get. So yes, I think it's done. Next, what we have to do is I'll show this. So you can see all the content of that database has been stored here. So you can see my content Intellipaat at gmail.com, Intellipaat1, Intel at gmail.com, Cody at gmail.com. So all the data is stored here. So I just have to run this so that all the changes are made in my Aurora database also. I'll just close this. I'll have to paste my instance endpoint over there. So I'll go to my RDS console and then copy my cluster ID. After that, I'll put it over here. That will be my host name, and I'll have to provide the port number. After that, I can run this. So if I run this, these changes should be made in my sorry. First, let us try to connect into our instance. So username is admin. My port number is 3306. Password, host name, just copied it. So yes, I am able to log into my Amazon Aurora database. So So yeah, you can see there is a registration database. So while creating the database, I gave a default database name as a registration. So sorry, not default, the initial database name as a registration. So once your database is spun up, so you can go inside and check whether that database name is created. Yes, a registration database has been created. So right now, I'm trying to dump my content of that inside this. So that should happen seamlessly. I don't know what is the problem with this. So check with this endpoint. So can anybody tell me if anybody knows what exactly is this problem? Did not face this before. Specified key was too long. Max key length is 767 bytes.
Open this registration SQL.
Registration?
Yeah, open this registration.sql.
Yes.
Like the data.
Maybe column length as to create table users username, email, primary key, dump in the data.
Okay, what is wait. So you are inserting data in users table, right?
Yes.
And what is this third column? Can you go up when you create this user table?
Password.
But it says line 25.
Line 25 is around here. Sorry, it's around here.
You could view lines. View line. Okay. Sorry.
Go down.
Yes. So I'll try to just create a database. Sorry, I'll create the same table inside it. I'm not able to jump it, so I'll just log into my database. And okay, so what I'm going to do is I'm going to do the same thing, but not with the SQL file. I'll just create a table and I'll insert some data. I'll just register it and then I'll sign up. I'll just use this. So okay, so now you know that my application is connected to a local database. So now to make it access my Aurora database, so it's pretty simple. You have to enter your code. So my code right now here is doing server.php. So I'll open. So yeah, so here I provided localhost, root, and registration. So here I'll have to provide my endpoint. Here I'll have to provide my username and my password. So my password was admin123 and my username is admin, and I'll have to provide my endpoint over here. So now if I provide my endpoint and save right now and just refresh it, now my database will be shifted to Amazon Aurora. So it's just simple to change it from here to there. So right now let me just copy my writer. So yeah, so I'll paste it here and I'll save it. So done. Now I'll just close it. Now if I try to log in, I'll not be able to log in because there is no content. I'll have to sign in. Sorry, I'll have to sign up. So first let me sign up. I'll sign up as Intellipaat @gmail.com. Again, I'll provide Intellipaat and Intellipaat. So now before doing it, let us first check whether there is any data in one. So it's an empty set. So once I click on this, my Aurora database should have a table inside it. So let me click on registration. So yes, it has logged in, but did it create a table? Yeah, so it created a table in my Amazon Aurora database. So the transition was simple. So even a person who is using and suddenly the endpoint has changed, there will be minimal, there will be very less time taken to shift from your local to your Amazon Aurora database. You just have to shift the content. For that, you'll have to import your data into Amazon Aurora database. So once all the process is done, once everything is consistent, then you will have to shift from your local to Amazon Aurora. So right now the data is stored over there in my Amazon Aurora database. So now I think you get the point here. So because we've used localhost now to access Amazon Aurora, it's very simple. You just have to use its endpoint. So that's where its compatibility comes in.
Okay guys, a quick info. If you are looking for AWS certification training, Intellipaat provides a complete AWS Solutions Architect certification training, and those details are available in the description. Okay guys, we have come to the end of this session. I hope this session was informative and helpful for you. If you have any queries, please comment it down below and we'll love to help you out. Thank you.